Ramanujan was a self-taught Indian mathematician born on December 22, 1887 in Erode, India to a poor Hindu family. By age 7, he was transferred to a high school where he held a scholarship and stood as first in his class, excelling at mathematics, and by age 12 was considered a child mathematician by his teachers. He continued to excel in maths as he grew up, independently synthesizing many previously understood problems in mathematics and gaining scholarships. It was around this time that he became published in the Journal of the Indian Mathematical Society, wrote many articles, and began his correspondence with Professor Hardy, attaching 120 theorems to the first letter. In 1913, he was given the first research scholarship at the University of Madras, despite not having an academic degree. In 1914, he was invited to Cambridge University, where 2 years later he received an honorary degree. Although he had almost no initial formal training in pure mathematics, he made extraordinary contributions, especially in areas of divergent series, definite integrals, number theory, and continued fractions, many of which are commonly used in today's mathematics. Ramanujan was elected to a Trinity College Fellowship in October of 1918, a prize that would last for 6 years, cut tragically short by his death in April of 1920.
Ramanujan's conjectures have inspired numerous mathematicians to enlarge the construct of mathematics brick by brick. His mentor, Hardy, was one of the first to be inspired by the superlative nature of Ramanujan and his results. An example of one of their 30 influential collaborative papers being the Hardy-Ramanujan theorem concerning prime factors of the natural numbers, gave rise to a new branch of mathematics called the probabilistic number theory. This was further developed by mathematicians Erdos and Kak in the 20th century. And from this development, we can tie this approach to modular forms and deduce new theorems about prime divisors of Fourier's coefficients of modular forms. Ramanujan's true mathematical genius identified for mathematicians important directions in which to work.
Ramanujan had an exceptionally hard time communicating his ideas to others due to the fact that he was majority self-taught. This meant that he gained most of his knowledge from an at the time outdated textbook that only expressed short proofs, so in turn Ramanujan neglected to properly prove his work. As a result, his colleagues did not commonly accept his works. This became a critical obstacle in Ramanujan's mathematical career, as he had to alter the way he worked and calculated to reach the standard needed for other mathematicians to see his work as being correct. In addition to this, he also faced many other obstacles, including the fact that it took him 11 years to be accepted into a university and hold the position. This was a serious complication in Ramanujan's career, as it wasn't until he received a job in an accountant's general office due to a glowing recommendation that his career was really able to take shape.
Many of his theories are the basis of areas of study, primarily the Ramanujan theta function. The Ramanujan theta function is fundamental to bosonic string theory. Matsukaki, father of modern-day string theory, explains that each of the 24 modes in the Ramanujan theta function corresponds to a physical vibration of a string. Whenever the string executes its complex motions in space-time by splitting and recombining, a large number of highly sophisticated mathematical identities must be satisfied. These are precisely the mathematical identities discovered by Ramanujan.